My name is Sam Snider-Held. I'm a virtual reality and augmented reality creative technologist at MediaMonks. We are a full-service digital production partner. That means we make everything from websites to television commercials to apps to banner ads. And in the last couple of years, we've been doing a lot of virtual reality, augmented reality, and mixed reality. And we've recently just opened up a research and development department called MediaMonks Labs. And the reason is that if you're going to create a lot of really cool and fun activations for brands that use the latest technology, you kind of have to have a little bit of mad scientist in you. And so you can think of this as our mad science wing. And what I'm going to talk about today, the theme of this talk, is definitely falls into that mad science category. I like to call it Cyborg Creativity. And it's inspired by this event in 1996 when Garry Kasparov, the world's leading chess player at the time, was defeated by IBM's Deep Blue, a chess AI. And instead of throwing in the towel, he and a bunch of other people got together and created this thing called cyborg chess. And that is a human and a computer going up against another human and a computer. And another word for this is advanced chess. And that's because the levels of chess that you see playing this game are much greater than what you would see with two grandmasters versus each other or two computers. And the reason being is that it allows the human and the computer to become this sort of symbiotic mental being. And what I find is interesting about this is that the people who are the best cyborg chess players are the ones that can create their own AI for chess. And that's because they get to determine the nature of this symbiotic relationship. They get to sort of engineer a part of their brain. So what this talk is about is what happens when we apply this line of thinking to creativity. Now, I've been thinking about this since around 2010, and at that time, the new wave of VR hadn't happened yet. So no one was thinking that you would jump into a virtual environment and paint a 3D environment with a 3D brush. The other thing that hadn't happened yet was this whole new boom in machine learning and deep learning. I was getting into machine learning at the time, but you really had to have a background in mathematics, computer science, or academia, whereas everything I'm going to show you today I've learned off of YouTube. So it's a huge difference. So this is called Enhancing Creativity with Machine Learning in VR. And it's based off of three premises. The first is that, to me, virtual reality is the closest thing humans have come to engineering something akin to human imagination. It's a fully infinite three-dimensional space, and every section of that space I can control what's in it and make it look like the way I want. The only thing that's keeping it from being an extension of our imagination is the interface. While programs like Tilt Brush and Quill do a really good job of minimizing the user experience and user interface, I feel like a lot of VR and AR applications are still steeped in 30 years of two-dimensional design thinking that was based off of the requirement of a 2D screen and a mouse and keyboard. But creation in VR and imagination wants something way more free, way more natural. And so I think that machine learning is the key. Now, machine learning is the ability of a computer program to develop a generative or predictive model about the world by showing it lots and lots of samples of data about that world. So for instance, you show a picture of a car or lots of pictures of cars, and then it can say, hey, look, there's a car. Or, hey, look, I made a picture of a car. So what does this have to do with virtual reality? Well, machine learning, especially deep learning, requires lots and lots and lots of data. But when you jump into a virtual reality application, essentially everything you're doing is being turned into data. So for instance, everything you look at, everything you interact with, every movement your body makes, all that can be analyzed by and watched by a machine. So we're going to get a lot of virtual reality applications that get really good at watching you, understanding what you want, what you're going to do, and possibly even mimic you. And if you think that sounds a little bit creepy, that's because it is. But that's not what we're talking about today. That's a whole other presentation. What we're talking about today is working towards an ideal application, my ideal application, and that's basically technologically driven lucid dreaming. I have three explorations. I haven't gotten there quite yet, but hopefully one day we will. And so the first one is gesture control. So this is inspired by my first forays into 3D level editors within VR. I found that they were really clunky, they weren't natural, and they were steeped in all these menus, and it just really got in the way of doing what I came there to do, which was to create things. So what if I could use a machine learning approach to do something like, if I want to take a primitive, like a sphere, I can just draw a circle and then a sphere pops in. Or if I want a cube, I can draw a cube and then a cube pops in. And so that's what you're seeing here. This is a machine learning approach where the machine learning is trained to recognize my sketches. It's based off of Google's AutoDraw, in which you can draw a pretty crappy birthday cake, and it will give you a better birthday cake. And so the first tests were like this. I developed an interface where you could draw. So here I'm drawing a tree, and then after I draw that tree, I can then place as many tree sizes as I want in this VR space. And then I can open the interface up again, and then I can draw a bush, and then at that point, I will be able to draw bushes. Yay, look, bushes. It can be more complex than that. So here I'm going to very slowly draw a super complex house. And so now I can place as many houses as I want. But it can also be even more random than that. So here I'm going to draw a school bus, or some version thereof. And it recognizes that I want to draw school buses. And so yeah, what's really cool about this is that it allows you to really pull whatever you want out of the thin air. And so yeah, that looks pretty cool, right? Well, the problem is that the symbols for certain objects are more complex than others. So for instance, here I'm drawing a plane, but it takes around 10 seconds to draw a plane. And at this point, it would be much easier for me to have a sort of speech recognition algorithm that's, I just say, hey, give me a plane, and then it gives it to me. But another way is that maybe we can use machine learning to sort of curate small menus for me continually, and then I can just choose from them. So that led me to this other type of machine learning approach called behavior cloning. Another word for this is imitation learning. And you can think of it like a surgeon's assistant. In TV, you see the surgeons in the operating room, and then they hold out their hand and they say scalpel, and then the assistant gives them the scalpel. But more often than not, these assistants are trained in the same domain that the surgeon is, so they will be watching what the surgeon's doing and try to anticipate what the surgeon wants, and then the surgeon just puts out their hand, and all of a sudden the assistant gives it to them without having to ask for it. So if we wanted to train a machine learning VR experience like this, basically I created a very simple 3D editor in which, as I'm going around and teaching it certain behaviors, it's constantly watching what I'm doing every frame and recording what I'm doing every frame. So here I'm teaching it that I like to place trees around in these circular areas, that I like to put bushes together, and that I like to put bushes next to rocks. And basically, I'm breaking down this task for the computer like this. When I saw this picture, I placed a tree. When I saw this picture, I placed a bush, etc. But this is where it starts to get really trippy, because if you can train a machine learning algorithm to understand what you're going to want to do, when you're going to want to do it, then what point do you still need you at that point? And can you train a machine learning application to replace you? And the answer is yes. This is a video of that machine learning algorithm running completely by itself. And you can start to see it exhibit some of the behaviors that I taught it. So I taught it to place these trees in these circular areas that the grass is all on the ground. The rocks are grouped together like so. Here's a still of that, basically the same things with the rocks and the trees in these circular areas. And so I think this has a really sort of cool impact on procedural content generation, games like No Man's Sky. When building these applications now, you have a designer and a developer sit down and they figure out how they want this world to look like. And then they sit down and figure out all the rules for generating that world. And then it's up to the developer to sit down and code all those rules. But with the machine learning approach, what you could do is you have your 3D artists and they just populate a certain section of that world. And then it's up to the machine learning algorithm to understand and figure out what all of those rules are for that sort of experience. And then we can talk about productivity. For instance, if you have a machine that can do something like this, let's say you're pressed for time and you have to finish a certain environment by the end of the day. So what if you spun up a clone of yourself and the two of you could work in that same environment and populate it together? And that's just where the craziness starts. You could spin up 100 versions of them And if it was an optimized clone, perhaps those clones could run 1,000 times faster than you. And so you could start to look about how this can change work if each one of your employees can be 100 super employees. So we've seen that machines can place assets, but can they create assets? The answer is yes. This is Google's Sketch RNN. Here you see the computer programming drawing its own trees and bushes and flowers. They did this by creating 2 apps. Well, one app is Quick Draw, in which they asked users to draw certain objects. The first one being like a butterfly, and then here is a user-drawn butterfly. And they're able to do that. They use this to basically ingest millions of user-drawn data samples. So for instance, this is just a subsample of the bananas. All of these are user-drawn. And then they ran it through a network called Sketch RNN, with the point being that they wanted that network to understand what a banana drawing looks like. And a good way to think about what it means for a machine to understand a drawing is that it wants to graph all of those drawings in a meaningful way. And when I say meaningful, is that all drawings that look like each other should be placed on that graph in the same area. So if you look at the top right-hand corner, all of the bananas are facing one way, but if you look at the bottom left over here, they're facing a totally other way. So it's basically what a machine learning algorithm is trying to do with this data, is just graph it meaningfully. And when you do this, when the machine can do this, a lot of crazy stuff is possible. For instance, it can generate new data. So these are cat drawings drawn by Sketch RNN. These are not user drawings. And it did this just by doing something like this. It takes a look at that graph, and it says, I know where all these user-drawn bananas are, but what does a banana look like from this point? And so it takes that point and runs it through the neural network, and then you get a new cat drawing. Another crazy thing is that it can do lots of really cool transformations and arithmetic on those drawings. So here is a linear interpolation between 2 different pig drawings. So you see this one picture of the pig on the top left, and then the one on the bottom right. And then it can figure out all variations of drawings in between them. So as it goes down this line, the pig drawings start to look more and more like the one on the bottom right. So that's what this would look like on that graph. You take these 2 points, and then every point on that line would be a new drawing. So what does this mean for virtual reality? Well, essentially, it allows you to create a machine that can draw with or for you. To create a machine that did this, I made a tilt brush clone in which I can draw anything, but for this example, I was drawing trees. And all I can do in this is draw points and then control the stroke width of this. The simplicity of it allowed me to draw around 700 examples in 3 to 5 hours. And then here is a 2D representation of that data. So yeah, there's lots of different variations of trees here. These are ones drawn by me. I fed these through a generative adversarial network, and these are trees drawn completely by the machine. So it's not 100% my style, but it does learn certain things. First of all, they're all trees, or most of them are trees. And then they all have this sort of tree, leaf, bush area at the top, and then some of them exhibit this sort of bend to them, which I taught it. And then here's that cool sort of interpolation between them, between 2 different points in this graph. So one way to think about this is that I've effectively abstracted a portion of my creativity or aesthetic sense or imagination into the neural network. And that each one of these drawings is a single point in the graph of all possible drawings in my learned style, or an interface between this drawing and every other possible drawing in your style. I know this sounds a little complicated, so it's basically allowing you to art direct a copy of yourself. What this looks like, an example of this is here is a version of one of these ML tree instances. So I've placed this in a VR environment, and if I don't like the way a tree looks, instead of drawing a new tree, I just push it through that graph. And so what I'm doing here is I'm just moving my thumb along the thumb pad on my Vive controller, and it morphs the tree through all these possible variations. And then here's a look in situation. I sped it up for time's sake. So here I'm doing 2 things. One, I'm placing machine learning trees, and I'm also drawing an environment for them to live in. So here, this is basically tilt brush clone, and I'm just shading in some stuff. And then here, I'm going to slow it down a bit. And so now I can interact with these trees like a normal 3D asset. And so now I don't like the way these trees look, so instead of redrawing them, I'm just going to sort of have the machine draw different variations of them. And then make them all look a little bit like each other. So it's a little bit of a mixture of me thinking creatively and the clone of my creativity thinking creatively. The output of that looks like this. And so this is a mixture, sort of a symbiotic relationship between me drawing and the machine drawing. Here's another example, and then another example. And then, so yeah, just to round this out, just a few questions to think about for the future. Can machine learning create new procedural generation interfaces? I think so. I think that this will allow 3D artists to have a lot more natural way to create these procedural worlds without having to work with a developer. Can we use machine learning to mathematically describe our creativity? That's essentially what we were just doing. I think a lot of people might see that and see it as a negative thing, like we're taking away the mystique of our creativity, but I really think it's just a new way to interface with our own creativity and allows us a whole new sort of creative tool to use in our arsenal for art. Will machines take our jobs? Yeah, I don't know. I think a more interesting question is, instead of some sort of nameless application automating your job, what if it's you automating your job? And what does that mean? Does it mean you get to take more days off? Or does it make more money? I don't know. And then the last one is, can machine learning make us more creative? Well, I think by now you know my answer to that question is yes. I think it's beer time now. So if you want to contact me or work with us on this sort of stuff, here's my MediaMonks email and then my Medium post. Thank you.
Thank you. Thank you very much. We have some time left for some questions. So,
no questions.
There's one? Perfect.
Oh. Woohoo.
I'm always happy when.
Are you through the neural networks, are you rasterizing it into two-dimensional data always, or are you really working with the three-dimensional data?
Oh, so for the first example, that was two-dimensional data. I would draw it, rasterize it, and then send it through a 2D network. The last one is three-dimensional. It's actually four-dimensional data. It's X, Y, Z, and stroke width.
Awesome.
Yeah.
And is it all with a GAN or an RNN?
I used a bunch of different versions. I used, the first one is just a convolutional neural network. The second one was a combination of recurrent neural network and a convolutional neural network. And the last one was just a generative adversarial network. Yeah. So, any more? No?
Yes.
Oh, can't see.
On the format of files that you can run through those different networks.
What was the?
Limitation on the file formats?
Oh, yeah. The neural networks don't really care about the data as its input. It will learn whatever it wants to learn based off of whatever you throw into it. So you can throw in JPEG, you can throw in CSV, 3D models. It's basically all about the architecture. Machine learning is all about the data and the architecture. And the solution is different for every sort of combination of those two. So, but you can do it on whatever you want. Yeah.
Over there.
Just curious how many hours of YouTube you had to watch to pull this off.
I don't watch TV anymore.
Hours.
Yeah, it's just YouTube. No, but Siraj is just Google Siraj on YouTube. That was kind of a lie. It was YouTube and Coursera, but it's all free. And it's one of the things that excites me the most about machine learning because it's one of the most advanced high-tech technologies that's ever existed, but it's also the most open. You don't have to go to school for it. You can just learn it on YouTube. So it's really exciting.
So the things that in the demonstration, things that we were making the machines to do is to sort of recreate our reality in different forms and different variations, right? But do you think if enough time passes by, do you think the machines will be able to create something that's better than the reality, that's not basically not using the reality as a reference, but creating its own reality so that's better than our reality?
It's kind of like the Matrix, right? Yeah, I don't know. I mean, your brain wants to perceive whatever it's given to. So maybe in time, we'll develop new neural connections to perceive stuff that, I don't know. I don't know. It's a fun question, but I don't know. For me, what we're talking about is not hardcore AI. We're talking about machine learning. It's basically using a machine learning algorithm to develop functionality without having to code it specifically. That's a good way to put it. So for the second sort of exploration, instead of coding rules for doing a procedural world, I just show it how I want it to happen. And so it's more like a procedural thing versus like it understanding what the world is and stuff. It doesn't understand anything about the world. It just understands the data. So.
So when you're training this model, so assume you've been at it for a few hundred hours now, and your creativity map is huge. Does it take longer for it to identify, let's say, 2 points of reference, or does it really get complicated if the points of reference are like too far away?
Yeah, a lot of the researchers will say that machine learning is very alchemical. It's like alchemy. And the reason why is that the models are always really dependent on the data set and your architecture. And so it's more about, I have this problem, I have this data set, I need to figure out a model for that data set and model. If you have a single point in there that's so different than everything else, it will never get a really good idea about how to deal with that one. So if you're training it on bananas, and then you show it a picture of a cat, it's just going to be, this is a weird looking banana. And that's how it's going to approach it. You have to set it up for a task to be like, we're training this on cats and bananas. And then it'll be like, oh, okay, so this is a cat, this is a banana. So you have to kind of set it up for that. And then training is just dependent on how accurate you want it to be and the size of your data set.